You ever crushed a valve with a GoPro before?
Break it already?
Not yet.
If it's just gonna sit in there like that, I'll make a run with it in there.
Alright, we'll be like that guy with the blender.
The will it blend guy?
Yeah, the will it blend guy. Holy shit. Welcome back to the channel. Today we're at Edelbrock's facilities. We're gonna go take a tour. Let's go see what's going on inside. I'm excited to be just an absolute sponge and learn a ton today. So this was done by a local street artist. There's references to Tennessee and California. It's pretty cool.
Purchased this as a warehouse facility. It was pretty mostly unused. We used about 3/4 of it. Driven Racing Oil was based out of here. Race Quip. So you had a lot of other brands in here other than the comp brands that were in here. But if you look down the aisle here, everything on the left is all finished good inventory that's part numbered, UPC'd and ready to go. Everything on the right hand side is all bulk, the manufacturing side.
This is like, I wish I could just come live here. Look at all the cams. You got cranks over here. I mean, this is like car person's dream right here. Heads on heads on heads on heads. These are all carburetors.
Like carburetors are carburetors, like this is all of the part numbers of carburetors. And it's the UPC barcode because the gun knows, or the computer knows that space is available for them to put a pallet of that size and that weight onto the shelf. That's how they get packaged to us and sent to us from California. All of these are manifolds that are came from our foundries.
Shipped from Cali.
See how that hadn't been cut yet, machined?
Yep.
We cast all of these valve covers over in California as well. So this is an FE Ford intake manifold. If you look, it's not quite finished. There's some things that need to be final done. When you CNC a intake manifold, it's not all done in one shot. One machine may do only 1 or 2 operations on it. Others can do the entire manifold in one setting. Anytime you see that little square on the intake manifold, it's where the Made in the USA sticker goes at the end.
Hell yeah, brother.
See how these are all rough? None of the CNC work's been done on it. So the throttle body hasn't been cut, indexed, the top hasn't been milled down. None of the ports for the injectors have been cut into there. Comes to us like that from powder coating, ready to go on the CNC machine. First step in an intake manifold is cutting the flange. That flange will index into the machine. Every other critical dimension on the intake manifold is indexed based off of how the flanges were cut. So that's why it's done first.
Looks all pretty now.
Yeah, getting there. intake manifold has a master. That master is the master casting of it. It's got all the master markings on it, and when we're indexing the machine to get it set up to run that manifold, we come get the master, they index the machine off the master. It doesn't matter how good your template is on the cylinder head, the intake manifold. Sometimes there's nothing better than just being able to bolt that intake manifold up to a block that it's actually going on, so you can verify that things are correct. That's why you got a lot of different engine types that are up here, because we will occasionally come up here and just verify that something's right or wrong and needs to be corrected.
Probably saves you a lot of time.
A lot of time, a lot of money. Hey,
Holy cow.
Yeah, wait. Put your hand.
It's a hoss.
that's our new chrome plasma finish. It's a powder coated finish.
Wow.
It's not a chrome plating.
It's powder coat.
Powder coated. It's right in the middle of it, so it's all oily from all the CNC work. You put a thumbprint on there, and literally, it just wipes right off. You don't ever have to put mothers or polishing compound or anything on those. They just wipe off. Flathead Ford, the original Flathead Ford slingshot manifold.
Look at the unfinished.
Yep, all gotta be cut out of there.
Casting material, yeah.
Pretty cool. Pocono, Knoxville. Everybody calls the CNC by their name, not by the Haas number 7 or 8 or 12. Yeah, very, very cool.
Easy to remember.
Yeah, and it's fun to talk about a racetrack.
Oh yes.
When a manifold is done and it's CNC'd and machined and done, you have to clean all the chips off of it. The oil has to be washed through that washer first. It goes through a pretty long wash cycle. It goes to a final inspection table. They'll just verify that all the holes are drilled. A lot of them will go into the QC lab where they'll actually do some physical measurements of the intake. Right now they're just doing a quick visual inspection.
So we're gonna go into the QC lab. I don't think anyone has seen this before on YouTube.
It's obviously climate controlled in here.
Yes.
Anytime you do quality control of anything, it needs to go into a humidity and temperature controlled environment, so you make sure that there's no changes to the material. When we start talking about things that we'll see tomorrow in the cam shop, it makes a big difference of what the actual temperature is, not only for the product, but for the test equipment that you're testing it on. They will put it on 30 Yeah, they will put it on a granite table. It's been leveled. It's got the right surface area to it. Obviously, they've got some small block Ford stuff that's outside that they're getting ready to cycle through here. There's another gauge for a Vortex, small block Chevy, just to make sure that everything was indexed correctly. And it's ready to be boxed up and go into a package at that point. We'll get the manifold out of manifold production, and then it comes over here. They'll put the injectors, fuel rails, any of the sensors that need to go in there. It goes through a wet QC to make sure that it actually flows, the injectors work, and it gets cleaned up, boxed up, and ready to go.
Shipped out?
Move it out. They do a lot of complex assembly stuff. A lot of our EFI stuff is done here before it goes over to the final packaging area. So this is our packaging area. A lot of things that come into here are not a finished good until they've actually been packaged, have instructions put in, stickers, any of the labels that need to go with it. That all happens here. Once it's done here, it's done. It goes to a pallet that can be put on the shelf, and it's ready to go at that point.
Sweet.
All this will leave by the end of today.
Wow. So this is all just today.
Just today's inventory that's been pulled. When they come to pick up, they will pick up all those pallets.
Wow.
Buy a lot of bar stock. That's the beginning of something, whether we end up cutting it and making a couple of different cams out of that, or sometimes some of those really long bed cams are for tractors, Cummins, John Deere, like industrial type stuff.
What is that out of?
Anything with a really thick barrel, really large journals, and really narrow is a pro stock pro mod.
I'm making some sack.
Everything that's in that bin is all regrind stuff. Some materials you can regrind quite a few times. Tool steel, because it's hardened all the way through, you can grind that down to a nub. You won't have any lift and duration left on it, but you can literally grind it all the way down. Whereas other cams, the heat treating only goes so
far
deep in it. Yeah. That's a cast cam core. There's a couple of different ways of telling it's cast. They're darker in color. The lobes are always parkerized. It's just an anti-rust, anti-wear. You can tell it's cast because it's got the casting lines in it where the two halves of the mold came together. And these go through a little bit different machining process than the billet cam cores. Oh, International Harvester.
Yeah, look at that thing.
That's like an 8620.
Crazy how much they vary.
Unground lobe. It's a UGL. It means it has not been finished. The journals are finished and done to size, but the lobes have not. You see they're kind of rough.
Yep.
They are a rough ground, the general shape of it, but they are not finished. This is what we call a core. See how the end is on that?
Yeah.
Very complicated cam core to make because the Ford requires that to index for the timing.
These are out of a Coyote motor.
None of these have anything on them, which means they are ready to be laser etched with the part number and a serial number of what it's going to be built into. All of those cams are going to be ground to whatever spec is on the instruction sheet. Creates a serial number for it. She's got to index it in there. A lot of times, instead of putting a part number on there, maybe they want the name of their car on there. Every time somebody touches that camshaft, they will put that serial number into the computer so we can track every stage of it. Every step of the way, we know who touched that camshaft. Mod motor cam. So that's out of a billet 5150 or 5160 material, and it's hollow. That material is a little bit different. You see it's all shiny and kind of chrome looking.
Yep.
It's because it's gone through a different machining process. And it goes through a polishing process that I'll show you back there. You grind a camshaft with a regular wheel or whatever, okay? This is the lobe. When you grind it at a microscopic level, you get a lot of peaks and valleys in the grind, right? Just happens. But when you talk about breaking in a camshaft, what you are doing when you break in the cam is it knocks down the top part of that lobe so you get more surface area for the lifter to ride on there. What that MSE process does, same thing, lifter, but this is a hydraulic roller. When you grind the cam and then it goes through the MSE process, it knocks down all those valleys and peaks. So now it looks like that. So now the lifter has way more surface area to contact it, makes it way more stable, makes it wear a lot better. That MSE process is something that we learned from folks at John Deere. They care about operating hours, and the longer it can run, the better. That process there keeps their parts from wearing out. You got about 97% of the lifter contacts the lobe. Whereas over here, you're in the 20-30% range.
Wow, that's a big
That's the difference in it. That's why that MSE process is so important to us. And we're the only cam manufacturer in the aftermarket that does that process. Very expensive to purchase these machines and set them up to do that.
What does MSE technically stand for?
Micro Surface Enhancement.
Learn something new every day.
Isn't that cool?
Yeah, that's wicked cool.
I like my artwork.
I love your art. You did a great job.
So he's getting ready to take the cover off of that MSE.
Look at how pretty.
People ask why we chrome plate our cams or not. It's just a polishing process.
They're just that good. They're just that polished. We're just that good.
That's the bath. I wouldn't stick my hand down in there, but what they will do is once it goes through the bath and it cycles through, that's a water hose where they just kind of knock off all the media that's on there, any of the leftover stuff.
What kind of a media are you guys using?
Top secret.
Top secret?
Yeah.
That's classified.
This area does all the rocker arm assembly. There's a bunch of trunnions, bodies of rockers. Any of the Hemi shaft mounted rockers are done here. These are a bunch of small block Chevy Pro Series, and they always cast the 152 as the ratio. So we know it's a small block Chevy. They'll verify the wheel, trunnion, and it'll get cleaned up and it's ready to go over to packaging to be put in a kit.
Make someone a happy customer?
Exactly. So this is our nitriding machine. Right now it looks like they're doing rocker arm shafts on there, but we do camshaft, crankshafts also go into that machine. What happens is that big cylinder will rotate over and go down over it, and then a chemical gas process occurs. Those could be in there for 72, 48 hours.
Wow. I didn't realize it was that long of a process.
Evacuate itself, let it cool down. It's an invaluable machine for us.
Yeah, that's crazy.
What he's doing in this first stage is to take that bar stock into something that's roughly started, but just a barrel. There's nothing that's been ground out. He's just cutting all of the basics into it.
So this is what goes in,
Yeah,
and this
that's
is what comes out.
Yep. So we talked about the dowel pin and being the index for the camshaft. None of these cams have dowel pins in it yet because the dog or the bit on the machine needs to index it into the CNC correctly. So it's bell based on the dowel pin.
You guys make these
Yep,
here?
absolutely. It's what the OE uses to grind all of the cams that go in, modern, whatever's on the road today. This is the type of machine the OE uses to grind those cams. They can do these very, very, very quickly. The Akumas behind us will generally take about 15 to 20 minutes depending on the material and what it is. The Landis, if we turn it all the way up as quick as it'll go, can grind a cam in about 3 to 5 minutes. We don't run it at that speed because you lose some of the quality out of the grind when you grind them that fast, but these are typically all of our really high production part numbers. Hopefully.
Is your favorite machine in the whole place?
That is cutting the cam here.
You can see it's starting to make cuts.
Because you don't want any sharp edges on the edge because the wheel will cut all that. So all he's doing is just grinding that, taking that off.
Deburring.
Yep. You see how on the floor there's that cut?
Yep, so you cut this out, reinforce it, and re-pour the floor.
Sort of.
Sort of?
So it took us quite a long time back in the 80s to figure this out. But every time the train would go by and the machine was running, it would change the grind on the cam. You'd get chatter marks on it. And they couldn't figure out where it was happening or when it was happening. But because we serialize everything, we know what date and time it was all done. They started going back and looking at, okay, what serial numbers were affected, what time were they ground, down with the railroad to see what time the trains was hitting this, and we figured out it was vibrating the floor.
No way.
So they cut the floor to isolate it.
Note to self, because I do construction as well, and I do a lot of work near train tracks.
It was a big deal back then because they couldn't figure out why it was doing it. They were changing grinding wheels, they were changing the setup.
That must have been so hard to pinpoint because
How do you do that?
It's sporadic.
I know, it was totally. If you get a run of camshafts, it would go through.
Half of them are good, half of them are unaffected.
Yeah, and it's not like, you know, cams are done, you know, once a minute on these machines. It may only be one or two cams, depending on how many machines are running. For a whole batch, but insane, totally insane. Back, you know, 80s, 90s, Comp did almost all the NASCAR teams' camshafts. They came from this facility. The first employee that Comp ever hired in the 70s is still grinding cams today. Mr. Kenny Arundel, we're gonna go meet him right now.
Sweet.
What's up, Daddy-O?
How y'all are?
Good, man, how are you?
Well, I couldn't be better if I was. I'd have to be queen.
Billet, material is done on these Edelbrock machines in here. That's an unground low. He is indexing it, prepping the cam in there to be its final grind. Now it goes through a final QC process. I'll show you that in a minute. But this is where it all starts. If he's not comfortable with anything on that, it's stopped. It goes to QC. They will retake a look at it, start over if they need to. So remember we talked about cams that can bend? What he's doing is he is checking on the journal the straightness of the camshaft. So this is our quality control lab. 100% of the cams that we grind in the shop go through this lab. Everything. Everything gets measured, verified what it was ground to. You see how the probe is coming over? What that'll do is it'll ride in a couple of different spots on that cam lobe to measure exactly what the lobe dimensions are, height, everything. Right now, it looks like they're just indexing. The reason why on the Adcold machine that everything is done vertically, it would measure the natural bend of the metal as it's occurring just by sitting there. Because it measures so far below under the decimal point, it would pick up that slight deflection in the middle of that camshaft.
That's crazy.
That machine will measure 7 digits underneath the decimal point.
Wow.
Because every camshaft has a serial number on it. If you buy that camshaft and 10 years, 20 years down the road, you call us with that serial number, we can pull up that Adcold report from the day that she did that on the machine, and that information was saved into the computer. So we know exactly what that cam started out its life as. Our research and development area. It is restricted. We don't allow a lot of folks back through here, but I'll give you a full tour of it.
Oh, thank you.
We don't allow a lot of people, but
This is so cute. It's a little camshaft. Love it.
What the Spintron will do is it'll start at 3,500 RPM, come up to 65 or 6,800, whatever, hold there for a couple of seconds, and then bring it back down to 3,500 for millions of cycles. Millions of cycles. It would be the equivalent to putting a couple 100,000 miles on a vehicle. That gets us the wear patterns. That gets us the durability of it, the stability of the valve train. Because within every spot here, there's sensors we can put on the camshaft, on the springs, on the push rods to see how much deflection is in there. We can measure all the things that are happening on the load with the camshaft on the machine. So it tells us every critical point of data on there to know exactly what the camshaft is seeing throughout the whole process. Once we've confirmed it, the wear's good, then it goes over to the dyno and says, okay, now let's see what makes for horsepower, and let's see how it reacts over there, and then any little tweaks that need to be made can be done there before it goes into a test vehicle. But literally everything starts with the Spintron.
So this is the room. This is the
where
machine. This is where all the magic happens.
Yep, and then we overlay it versus the idle trace or the 1,000 RPM trace. So then you can actually see, like, as your valve train deflects, it starts to get smaller and smaller. You actually lose a little bit of duration with higher RPM. Yeah.
Wow, that's crazy.
Yep.
And that's something you'd never know unless you have this set up. Right? That's so cool.
Yeah.
And that's why comps is step above everybody else. It's a fucking truth. I mean, whatever. That's so cool.
We don't necessarily do the greatest job talking about it, but we do a really good job of testing our products.
Yeah, I'm thoroughly impressed.
But this specific engine just went through a 10 million cycle durability test of our new DLC flat tappet lifters. And because of our awesome QC lab over there, we were actually able to remove the cam during different portions of the test and look at the surface finish of the cam throughout the test to make sure how much wear we were actually putting into it.
Yeah, and at what point, too,
Yes.
with the graphic. That's so cool.
So we
Oh
know
my God.
basically to the 10,000th of an inch of how much wear we put into this cam, 10 to the -6 inches.
Yeah.
So
Wow.
it's 2 spots further
That's so
than the
cool.
10,000s.
Yeah.
But yeah, so you're looking at very, very small differences, but it helps us get an understanding of how the parts are actually loaded.
Man, that's so cool.
That's really cool.
Yeah.
And I can show you all some of those graphs off camera.
Oh,
Yeah,
I'd
we'd love to
them
see
off
it,
camera,
yeah. But 800 RPM, it's 1,000 now. Yeah. Holy shit. I really can't believe how loud this is with no bottom end. There's no pistons, there's no crank, there's nothing in the bottom end. It's just something I never thought about, I guess.
We can put a camera up in there, big
Yep.
window cut in the block, and you can see what the valve train's doing.
I have an idea.
Can we put a GoPro on the Spintron?
Yep, we're good.
It'll stay
Think
there.
it'll sit there?
Yeah, it'll sit there.
You ever crushed a valve with a GoPro before?
Break it already?
Oh, yeah.
Not yet. Hopefully not.
We're about to. It's cool to see that. If it's just gonna sit in there like that, I'll make a run with it in there.
All right.
So I
I got another GoPro, so I mean.
Well, I won't.
We'll put it under the valve cover and just tighten it down.
It will be like that guy with the blender that destroys all the shit with a blender. We'll just do it with a motor.
Yeah.
The will it blend guy?
Yeah, the will it blend guy.
So long.
Will it blend? That is the question.
Alright, so this is going to be a 4,000 to 7,000 RPM sweep. And it'll
Okay.
be 4 cycles of that.
So 4,000 to 7,000. Okay.
Ready?
Yep. Now you can hear me talking. You crushed a valve with a GoPro before? I know, right?
As long as we have all of our valves, we should still have your GoPro.
No. The GoPro's hot.